Okay, welcome. Today we are going to be reviewing absolute value inequalities. And I'm going to tell you guys right now, this is going to be some pretty fun stuff. It might be a little challenging. This is something that even my guys who I have in 10th and 11th grade, they could struggle with a little bit when we go over them. But we're going to break it down for you guys. We're going to start off really simple and show you a few examples. So obviously here, I have an inequality and I also have an absolute value sign, right? I have the absolute value of x is less than 4. Well, we know in the past, say we had just been given x is less than 4, right? I would throw this on a number line down here. All right, well, this is where x is equal to 4. Put a circle around it. Boom. Everything less than it is a solution. Well, in this case, what happens? What happens, say I got to a value over here like x equals -5. If I take the absolute value of -5, that's equal to 5, and we know that 5 is not less than 4. That is not a true statement. So what do we want to do then? How are we going to make this work for us? We know that we can't just draw the arrow all the way over to the left. The absolute value of x is less than 4 is going to be different than just x is less than 4. Well, if we remember solving our absolute value equations, we would split it up and we would say, okay, well, x is equal to 4 and x is equal to -4. We take what's inside of that absolute value and we set it equal to the positive and negative of the other side. Well, what we're going to do here, what we are going to do here is instead of setting it equal, I am going to start by just saying, all right, well, I'm going to take whatever's inside, keep the sign the same, and set it to the positive. So here I just wrote, okay, x is less than 4, but then we need to use a compound inequality. So x is less than 4, and x also needs to be not less than -4, but now we need to be greater than -4. So we keep the sign the same for the positive, and we switch the sign, we flip the sign for the negative. Think of it like multiplying the other side by a -1. Okay, so we flip the sign for the negative, so we know x needs to be less than 4 and greater than -4. So down here, we are going to put a stop to this. Okay, we put an end to this. We say, all right, this needs to stop at x is equal to -4. Now, every single one of these solutions in between works. Okay, you could pick a number, pick the number as 0 if you want, plug it in, absolute value of 0 is 0. That's less than 4. -2, absolute value, that's 2. That's less than 4. So whenever we have a less than sign, we know it's going to fall between two values. It's going to be an and compound inequality. It's an and compound inequality. In this case, now we have a greater than sign. Here it's a greater than or equal to, but let's see what happens. Okay, I'm going to follow the same exact rules as that last one. So I'm going to take whatever's inside of the absolute value, just y. I'm going to keep the sign the same and set it to the positive. So I know that y is greater than or equal to 2. And then I am going to do the opposite. I'm going to say, well, then y, flip the sign so it becomes less than or equal to, and then use the negative of the right side. It must be less than or equal to -2. Whenever we have a greater than sign, it is going to be an or statement. Okay, whenever we have a greater than sign, it's an or statement. If we throw it on the number line, let's throw it on the number line, -2, 2. Okay, I said y has to be greater than or equal to 2, so I fill in the circle and go to the right. And y is less than or equal to negative 2, so I fill in that circle and go to the left. Okay, obviously this one couldn't be an and statement. You can't be less than or equal to negative 2 and greater than or equal to positive 2, so it has to be an or statement. Whenever we have a greater than sign, it's going to be an or statement. And on the number line, we will fall outside of the two values that we get. So here we fall outside of negative 2 and 2. Whereas when we had the less than sign, we fell between the two values. All right, let's get a little bit more complicated. We're going to show two more examples. Okay, again, here we already have the absolute value isolated. So I'm going to take what's inside. I'm going to say y minus 5. Keep the sign the same and keep this positive. Keep it as positive 4 there. So y minus 5 is less than or equal to 4. Now it's a less than, which means we are going to use an and. Okay, it's going to be an and statement. And then we're going to do the opposite. We say and y minus 5 must be greater than or equal to a negative 4. So I flip the sign and make this positive 4 into a negative 4. Now let's solve them both. So I'll add 5 to each side. I get y is less than or equal to 9. And let's solve this one over here. Add 5. Add 5. I get y is greater than or equal to 1. All right, so now I need to satisfy the both of these. I could also write this as just one inequality. I could say, well, y is greater than or equal to 1, but less than or equal to 9. And I throw this on the number line. Here's 1. Here's 9. Both of them are filled in. And because it's a less than, I'm going between them. I can also look here and clearly see, all right, I need to go between the two values. Perfect. Last example. Here we have the absolute value of negative 3z is greater than 12. So let's follow our same steps here. I write negative 3z. I keep the sign the same for the positive, so negative 3z is greater than 12. It's a greater than sign, so I use an or statement. Or negative 3z, now I'm going to flip the sign and make the other side a negative. So flip the sign to a less than and negative 12. All right, so now I need to solve the both of these. I'm actually going to take this top one and write it down over here. Negative 3z is greater than 12. Or negative 3z is less than negative 12. Let's erase this here and let's solve the both of these. So negative 3z is greater than 12. I'm going to divide both sides by a negative 3. Remember, whenever I divide or multiply each side by a negative, I need to flip that inequality. So now I have z is less than negative 4. And in this other one, I'm going to do the same thing. I divide the left and right by negative 3. I'm dividing by a negative, so I need to flip the sign. And I get z is greater than 4. So either z is less than negative 4 or z is greater than 4. Let's just practice throwing this on the number line really quickly. So less than negative 4. I'll put an open circle and go to the left. And z is greater than 4. I put an open circle at 4 and shade to the right. So it's greater than, I'm going to fall on the outsides, as you can clearly see here by my graph on the number line. Let's just plug in some values. So say you're not sure if it's falling on the outside, the inside, you're not sure. Well, let's try some values. Let's plug in a value that falls over here first. Let's try out negative 5. Right, if I plug in negative 5, negative 3 times negative 5 is 15. Absolute value of 15 is 15, which is greater than 12. Great. What happens if I try positive 5? Well, negative 3 times 5 is negative 15. Absolute value of negative 15 is positive 15, which is greater than 12. So that should also be shaded in. Let's just try a number in between negative 4 and 4. Let's go with the number 0 and try that. Well, negative 3 times 0 is 0. Absolute value is 0, 0. And that is not greater than 12. So great. That is not a part of my solution. So I know that I did this correctly.